So in the last two videos, I've been designing Cinewhoop ducts, but quite frankly, I'm getting bored of that now. So this time, we're gonna have a go at designing a TPU GoPro Hero8 mount for my Cloud 149 HD. Welcome back to Striking FPV R&D. My name's Ashton, and TPU is really flexible. This is actually the slammed duct design from my last video, printed in TPU, and yeah, this is way too floppy. I'd never fly with this for obvious reasons. So why TPU? Well, if you look at the thicker part of it, you'll notice that it's a bit stiffer. The great thing about TPU is that you can have it as flexible as you want, or as stiff as you want, to a degree, by modulating its thickness. So here's an old Hero 8 GoPro mount design anyway. And I've made it really thin, and as you can see, it just bends around like this, and that's not gonna be great for the GoPro because it's gonna flop around left and right. The PID tune's probably not gonna be happy with the oscillations either. Drone won't be happy, nobody's happy, forget about it. However, I decided to thicken up one side, and indeed, the increased rigidity has made it much more viable. However, the distance between the front bolt and the rear bolt means that it flexes this way from the base plate. So what we're gonna do today is redesign this and basically put in some channels for zip ties and work on little optimizations here and there. So let's get started. All right, so I've taken the liberty of removing the TPU mount because I need to get to the holes to work out the exact size to make the top plate. So the way we do that is we measure using our calipers the inside outer distances, and that is 24 millimeters. The hole diameter is actually 3, so 24 minus 3 is 21 millimeters, which is our center to center distance. So we create a sketch, select the ground plane, zoom in a little bit. Now we start creating our holes, type in 3 millimeters, another 3 millimeters, and we're going to use the sketch dimension, select the center of the hole, the center of the sketch, and type in 21 divided by 2, because you can type formulas. 10.5 is the result, so we can do the same thing for the other side and type in 10.5 instead. So now we got two holes 21 millimeters apart from one another. Now the rear two holes are a little bit further apart, so if we quickly measure them, we have 26 millimeters to the outer edges, which minus 3 is 23. So if I create holes on the bottom there, just type in 3, another one, type, oh, that's a little bit, no, let's not do that. I want to be on the same line. I don't have to be, but I want to. Now we set sketch dimension. We gotta set them 23 millimeters apart from each other. This is where it gets a bit sketchy. See what I did there? Click on the center of that hole, the center of the sketch, and this is not what we want. You have to move your mouse, not to the side, because that gives you vertical distance. Here is straight line distance. We need horizontal. So if you move it down, you'll get this position. Now we type in 23 divided by 2, 11.5. We do the exact same thing for the opposite side, 11.5, and there we go. Final thing to do is measure the distance front to back. Now, I could eyeball it and just kind of do this, but you can actually still get very precise because we know that they're, symmetrical, front and back and everything. So all we need to do is measure the straight line distance between those. That is what? 46. And because the holes are 3 millimeters, that means it's actually 43 front to back. So what I'm going to do, still with the sketch tool, we're going to select the bottom one, we're going to select the same side top one, and we're just going to move this around, as I showed you before, into the position that gives you the straight line distance, and we're going to type in what our number is, which was 43. But I'm actually going to put in 42.5. But why, Ashton? I'll tell you why. 42.5 because if, for whatever reason, we print a mount where the two holes are a little bit further apart what will happen is the total surface will kind of buckle just a little bit and kind of pop it off. But if we make it a little bit shorter than what it is, TPU being as flexible as it is, will then flatten itself even more onto the top plate of the drone, which is what we want. So with that, 42.5, and the exact same thing we're gonna do with the opposite side. Let's drag that there, 42.5. And now we've got our starting point. So what else do we need? Well, those are only the mounting holes, so we've actually got to create the outer section of it. So if I just measure this at roughly 7 millimeters, we can create another set of holes at 7 millimeter diameter, and that will start to give us a better idea of how much material we're going to be working with. 7 millimeters, done. Select the line tool, and we're going to select the side edge here. We're just going to draw straight down until we intersect the bottom line. Press escape to leave the line tool. Same deal on this side. Let's drag it all the way down. Press escape. Hopefully the audio isn't going to hell because of the weather. I'm going to try and edit the audio and keep it clean if I can. Gonna select the line tool, and same thing on the bottom. What I can actually do here, because for me, and you don't need to do this, but for me, I've got this grippy kind of material for the battery, and that kind of juts inward. So instead of drawing a straight line on the back edge all the way across, I'm going to draw it a little bit inset. So the way I'm going to do that is I'm going to draw a center to center line. Let's zoom in a bit. And from the middle, we're going to draw it downwards by 1.5. Let's just put in 2. And then we're going to draw lines across both sides. Press escape. And then we're going to delete our guidelines. And now we're left with that. The final weirdness is actually at the front here, because we've got this little indent. And that indent, little cutout, presumably is to help with the FPV camera if you point it really high up. So we're going to measure two things. We're going to measure the width, and the width is just going to be roughly the center of the curves across, and that is about 9 millimeters. And the actual depth, so the depth, we can use the bottom of the calipers and just awkwardly push it in. The depth is about 10. So we have 10 and 9. So using that, let's first work out where to draw it depth-wise. So the way we're going to do that is we're going to draw a straight line across, and from the center, we know that the front edge, if we draw upwards, is 3.5. So with that, we can use the line tool and draw it downwards. Type in 10 minus 3.5, 6.5. And then because the width is 9, we're just going to type in 4.5 on one side, 4.5 on the other side. Let's quickly delete our guidelines, and then using the line tool once more, we're going to draw from each edge. And the cool thing that happens is if you pull it up to this part of the circle, that little green icon thing means that it's tangent to the circle, which means that this line is going to join the circle perfectly for that curve. So let's do that on both sides. And now you can see this part's become a kind of see-through light blue, which means it's selectable. But we need the whole thing to be selectable, so we're going to click the trim tool and delete the inside edges of the outer circles. And there we go. Not done yet though. Let's make everything smooth. So using the fillet tool, we're going to click on here, type in 3, click on the other side. To do that, press enter. Same thing for the bottom here. Let's type in 3 and 3, press enter. And now for the sides. If you actually look at the design of this drone, this outer curve starts actually quite far away. So with that in mind, I'm going to use a very high radius number for our fillet curve here. So let's click that and type in 20. Why not? Press OK. Same thing for the opposite side, 20. press enter, and there you have it. Top right corner, click Finish Sketch, and we'll use the view cube to go to our funny oblique angle. Select the surface, press Extrude, type in 3, why 3? Well, I've actually been doing a lot of testing with these. I want this GoPro mount to be as low profile as possible, but you still need some meat on it to keep it stiff, so 3mm seem to be the ideal thickness, so 3 I'm happy with. You could make it 4 if you want it a lot thicker, but you also need to consider how much extra screw length you're going to need to be able to go through that. So for me, in terms of strength, rigidity, thickness, screw length, 3mm works. So with that, we've got our top plate design. Fantastic. Now what? Well, if you have some GoPro mounts lying around, like I do, here's a cheap one off the internet, you can do things like measure them and work out that, okay, 3mm, the gap is 3mm. So it's 3mm, 3mm, 3mm all the way across. But if I were to make mine only 3mm thick, I actually have a sample somewhere, there it is. You'll notice that it does this, it kind of flexes way too much. So to mitigate that, add more material. How do we do that? Make it thicker. This is another design that I did that worked really well, where this part here is not 3 mils, it's 6. So we're gonna do that. The final thing, if it's 3mm gap, 6 on the edges, is what's the actual total kind of thickness shape of it. So we can take the one from the actual GoPro, so you can see what we're dealing with here. The inside hole is 5mm, the outside is 15. So 3mm wide, 15 radius of the actual mounting point, and the hole in the middle, 5. With all that information, we can actually create our mount. So let's click the top surface, click on Create Sketch. I'm going to start sketching. So what do we want to do here? Well, there's a curve there that I'd like to get in front of. So let's use the front of that curve as our starting point. I'm going to draw across by 6mm. I'm then going to draw up by 15. And then we're going to draw back to the edge so that we have what we have. We have this first block that's 6mm thick, 15 deep. Now we need to create the other two. So we're going to draw across by 3mm, that is the gap. Draw down by 15. And then we're going to draw across by 3. And then up by 15. And then we're going to draw across by 3. This is getting repetitive. I'm going to draw down by 15. And the final bit, again, I can make this really chunky. So I'm going to make this 6. Draw all the way back up by 15. And I'm going to close off everything that we just created. Like so. Using the trim tool, we're going to delete the lines that created our gaps. And if we finish sketch, we should now have 3 chunks. And if we rotate to here, we're going to be able to extrude this upwards by what amount? 15. And now we're starting to get a little bit GoPro mount kind of looking, but not really. The next thing we need to do is create that kind of smooth top curve. And there's 2 ways of going about this. I could select that surface, create a new sketch, measure down from the halfway point, which is going to be, what, 7.5, create a circle all the way up, delete that marker, and use the trim tool to remove the bottom section. When I finish the sketch and go to this side, I can select these 2 sections there, press extrude, and completely shave them off all the way through. That's one way of doing it. But I'm going to undo, Control Z, Command Z, I guess, for Macs. Then we're going to select these top edges instead, and guess what I'm going to do? The fillet tool, 7.5, and you get exactly the same result in arguably a faster fashion. That being said, we now need to punch a hole through the middle, And we could have done that on the previous step as well. Because all we need to do is create a sketch, select the center point. Luckily, it's already got it there for me. Type in 5, because that's the size of the hole, finish sketch, and then select it. Why is it not selecting? There we go. Drag across, and there we have it. Now, it looks like a mount, except I know for a fact that it's way too thick. This screw will not go all the way through all of that. And in fact, now we need to create a couple channels. So for one, we have our mounting nut, and the outside diameter of this, please don't fall. There we go. The outside diameter of that is 8. But look how I'm measuring it. I'm measuring the thickness of one surface to another surface. This is important. Why? Well, let's create a sketch. So let's select that surface, new sketch, zoom in, and now we got to create a hexagon. So how do we do that? Click on the create drop down thingy thing over here, select polygon, and now we have 2 options. Well, 3. But the 2 that are interesting to me, we have inscribed polygon, which creates a polygon using the center point and a vertex. What's a vertex? Well, the vertex is the pointy part of the hexagon. And then we have circumscribed polygon, which creates a polygon using the center point and the midpoint of one edge. So the midpoint of one edge is that. So from there to there, I measured 8. So we're gonna use that. And I'm gonna select the center of the hole. And now we can create a polygon. Orientation is important though, because as I've repeated endlessly, 3D printing, you cannot print in midair. If you do that, the filament just kind of droops everywhere and it doesn't work out. Unless you do a bridge, which we'll get to later. So what we need to do is orient this hexagon this way so that you've got a little bit of a kind of upward angle that the printer can build towards rather than just full-on printing in midair. With this position, I now need to make it 8 millimeters in width. It's measuring radius, kind of, so we're going to type in 4, which is half of 8. And now we've got our nut cut out. Finish the sketch, select that cutout, press extrude, and type in -3. Press OK, and there you go. Now I can swing around this and you can see that we've got this nice little cutout for our mounting nut. However, with this, we're still not thin enough, narrow enough for this entire thing to go through. So what we're going to do is we're going to make an indent for this surface on the opposite side. So let's measure this. We are at, wow, that's specific, 10.6. All right, so let's swing around to the other side, create a sketch on that surface, and create a circle that is exactly 10.6 in diameter. Center, press finish sketch, select the surface, and extrude it inwards by, I know this for a fact because A, I got lucky, and B, rigorous testing. No, I got lucky. I can actually not make this -3. I can afford to make the whole thing a little bit thicker so that there's more meat to compress upon and more rigidity. So I'm going to make that -2 instead of -3. And there you have it. So now the actual mounting point is correct for accepting this, for accepting the nut. Everything's good, except it doesn't look particularly good. It doesn't look like it's going to be that rigid, especially you've got this whole area at the front that's flat and nothing else. So we're going to return to our chamfer tool. Let's select those front edges and click chamfer. And I can drag this out to 7. Actually, I can drag it out to 7.5. And that's perfectly fine. But you see, we've got this gap at the front that is kind of wasted flat area. So if you go to the type in the chamfer menu toolbox thing, you can set from equal distance and change it to 2 distance. And you'll now notice that we've got 2 arrows here. So the arrow for the vertical distance and the arrow for the front. So I can now drag this further out, and 12 millimeters seems fine. I'm going to click OK. Now we've got even more support. This front edge looks a little bit funny, so I'm going to select those, fillet them, type in 5, press OK. Now if we look from the side, we've got this nice kind of supportive shape, but not on the back. So, same deal, let's do it to the back. Let's select this edge and this edge. We're going to chamfer 7.5. There we go. And I'm fine with that. Click OK. Fillet these by 5. And everything's good. You might be wondering though, why didn't I do it to this one? Well, these screws are button heads, and you know, they've got a top surface that has to press down into the TPU. And if I were to select that edge with the others as I chamfered it, then it would go through that hole. And then you wouldn't have a nice place for the top of the screw to go down on. So I'm going to chamfer this separately, and we're going to set it to 7.5. You see what it's done? It cleverly keeps the hole there, but again, the screw is not going to be that weird shape. So I'm going to drag the bottom edge back until it looks like that looks about right for the hole that we're going to have there. So if I'm happy with that, I'm going to click OK. I'm going to select, let's get to the proper angle, select this surface. Oh, what's happened there? Oh, I didn't type 7.5. There we go, 7.5, click OK. And I'm going to select that surface, click chamfer 5, and now we're almost there. But Ashton, it looks perfectly fine. Aren't we done? No, we're not done, because the biggest problem, and I noticed this through testing and through things like this. Well, this is an unfinished print. I canceled it because I didn't like how it was going, but look at it. It's so floppy still. And I know for a fact that despite all the weird, things I've done, I've thickened it up everywhere, that it's still gonna have a little bit of upwards flex. And the only real way to get rid of that is to secure it down to the top plate. And double-sided tape is not the solution for that. I've tried, believe me. The real solution is zip ties. I didn't want to end up using them, but zip ties are really, really handy for securing things, and you get them really tight. They're fantastic. So I'm gonna make a nice way to put the zip ties on, because the last time I did this, I actually wrapped a zip tie around the front like this, and it looked janky. It doesn't look professional. It looks kind of weird. And I'm convinced that it wasn't doing as good of a job as a maybe purpose-built one. So what we're gonna do is we're gonna create channels for the zip ties to go through. So let's select this side surface, create a sketch, and we're just gonna find a convenient place to do this. So let's create a line to denote the top of our mounting plate. Let's escape there. And using the line tool once more, I'm gonna find a point on that line. Let's say that kind of looks fine. And we're gonna create our channel there. So to create our channel, we must know how big the zip tie actually is. So width-wise, we are just shy of 4 millimeters, and thickness, just shy of 1.5. So considering the flexible nature of TPU, 1.5 will do as a height, and 4 millimeters will do as a width. So down we go. That's going to be our first one. That's roughly in the middle of our entire plate, but we are securing the GoPro mount. So I actually want a similar cutout on the back as well. So the way I'm going to do this, let's just click roughly here, 1.5 up, and yeah, that's fine. 4 millimeters across, 1.5 down, and once more across. Trim tool to trim off the excess that we don't need anymore. And you'll notice that this part's behind the surface there. I'll explain a bit further a bit later. Let's finish that sketch, and let's quickly select these. We'll forget about that bit for a moment, and extrude them. And that's going to cut a channel all the way across to there. Click OK. Now, what do we do about that section? Well, we need to reveal it again. So let's open the sketches folder, expand it by clicking the arrow, and click on the eye to show the last sketch that we just made so that we can see the bit that is hidden. Now, I want to select that, but I can't because it's behind a surface. So, once again, using this little navigation thing, we're gonna click on the eye of the body, and that removes the actual model we've been working on and leaves only the sketch. And now we can select just that section. If I press extrude and pull it outwards, warning, the object that you are creating is not visible. Please toggle visibility in the browser. And this is crucial. So what you do, go to bodies and unhide it, and now you can see that our operation here is going to start cutting through things. So let's cut outwards first, click OK, and now if we're lucky, this surface is now selectable again. Zoom out again, press extrude once more, and pull it the other way to finish chopping a channel through the whole thing. At this point we can now hide that sketch, and there we go. We have 2 channels for our zip ties. All good. Ooh, here's an opportunity though. I just realized there's actually a lot of flat area on that side that we could reinforce. So let's select these edges once more. Not the whole thing. And chamfer. Let's select equal distance. We don't need too much fanciness. Oh, I see what's happened here. And that works for me. Click OK. And there you have it. I am now going to deem this design final. It's got all the elements that we need in a GoPro mount, including zip ties for extra security. At this point, we can save, so I'm going to keep it in the miscellaneous folder because my other folders for the Cloud 149 are really full. So Cloud 149 HD, TPU, GoPro Hero 8 mount. It's a long name. Click save. And the final thing to do is to expand the bodies folder and select the body, right click, save as mesh, STL binary because I fear the 3MF file format. Fear because I don't know what it really is. I hear good things about it, but no need for now. Click OK, and now we're going to select GoPro TPU mount V2. I guess this is V3 now. Save. Yes, replace it. Did I just replace it? Oh no. Oh well, whatever. So at this point, let's go to the 3D printer and see how it goes. And there we have it. Now I printed this at a faster printing speed than what I normally print TPU at, just to kind of get it done and prototype it. And you know what? It's got a few issues here and there, but for the most part, it seems to be fine. So let's push the screws into them. Because it's TPU, screws are a little bit of a tight fit. Let's see how well it fits on the drone. Dun, 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 dun. Oh, perfect. Absolutely perfect. All right, where's my Allen key, Allen wrench, depends what you want to call it, potato, potato. Screw that in. All right. Always a good idea. I do this on my motorbikes and car stuff. Loctite or any kind of thread locker is a good idea to have on stuff that you don't want to over tighten, that you don't want to seize, but you don't want to undo by itself. So something to consider. I'll probably do that later. All right, a little bit of flex on the base, which is to be expected, but that is what this is going to help with. There we go. Just gonna pop it through. Done. Now what you can do is, if you've got a pair of pliers, you can just use the pliers and twist them to kind of get more tightness on it. You hear it clicking. Do the same on the back. Once you're happy with it, doesn't need to be super tight. That's pretty decent. Use a snipping sort of cuttery tool to cut off the excess. This came free with my 3D printer. Thank you, Creality, very thoughtful. All right, now time to put the GoPro in. So let's get the feet, the GoPro in position. Slide them in between the gaps. Trying to get them lined up with the hole. Done. And we're going to push the screw in. You have to go past. Oh yeah, there we go. Going past the zip ties. All good. I'm going to use a screwdriver. It's not a good cheap GoPro mount screw thing that isn't made super well, so having the screwdriver to be able to help out with that is beneficial. Almost all the way through. I've stopped short because now I'm going to put the cap on, and that's going to fit in that hexagonal cutout that we made. How awkward is this? Done. Oh, not quite. Yeah, just go hold that and continue tightening. When that is on, angle it at the angle that I normally fly at, which is basically almost no angle, depending on what you're doing. Fantastic. Look at that. I made a thing. And that is kind of what it's all about. Being able to design, print, and create something with your bare hands. Well, I mean, build the 3D printer, which then prints the thing for you. Design with your hands on the computer. You have to be thankful that we live in the age that we live in. The fact that there's software that's free, 3D printers are affordable, plastics and all that stuff, and drones. I mean, FPV is so much fun. So yeah, there you go. If you thought that was cool, or if you thought that was helpful, you know, give me a like. If you've got any ideas for future videos, or you know, you want to know more about some other techniques in Fusion 360, leave me a comment. And yeah, if you want to see more videos like this, press subscribe. Thanks for watching, and I'll see you next time.